Assalamu alaikum, Bismillahirrahmanirrahim. In last class, we have discussed about OSPF. That is basically theoretical part we have complete. Today we are doing lab using OSPF. Basically, deploy OSPF. How to deploy OSPF for IPv4 and IPv6. You can consider this topology or you can extend this topology. Basically, um, that will be same. Just grow the concept and deploy your concept in small network, medium network, or large network. Just grow your concept. Okay. Today we deploy multi-area OSPF. So, what is multi-area OSPF? What is area? Okay. So we already discussed what is area. Area is just divided or segment your network topology in multiple portion or multiple section because of reduce the OSPF database. So if we reduce the OSPF database, our OSPF routing protocol will be better. So uh, in our lab, there are three routers here. We consider router 1 and router 2. Here we configure OSPF area 0. It's a backbone area. And router 2 and router 3, this part will be another area. It can be area 1 or it can be area XYZ. So this is very simple topology. So we deploy OSPF considering router 1 and router 2 area 0 and router 2 and router 3 connectivity will be in different area. Okay, so this is your guideline, which is basically collected from Juniper networks. Juniper network learning portal. I just copy the multiple step and make the slide. Every content is collected from Juniper learning portal. Uh, I should thanks Juniper learning portal for this fantastic document. So first slide, this is the headline deploying OSPF and how to configure OSPF in your network. It's basically depends on your um, network topology. Based on network topology, you decide how many area you need. In general, if you have more than 100 router, so you should divide your network in multiple area. It can be backbone area and to other non-backbone area. Okay. Typically, we consider a maximum 50 routers in area. If you have more than 50 routers in your network, you have to or you should divide in multiple area. Okay, that is the consideration when we consider multi-area OSPF. Okay, just you have only 5 to 10 routers, so you can run single area OSPF. That is not big deal. Okay, so okay, JNCIS-SP support Juniper device. Basically, WSPF is open shortest path first, and it's a open standard protocol. This is not the any proprietary protocol. So Juniper will support WSPF. That is WSPF have some features. Some functions like one feature is authentication. Yes, authentication support OSPF version 2 and OSPF version 3. By default, OSPF authentication disabled. Summarization can work through OSPF, but in summarization, you have to summarize in ABR, area border router. In area, summarization not possible. Okay, this restriction is for others vendor also, like Cisco, MicroTik, and others devices. And other features like authentication and summarization, you can limit external prefix. Just you redistribute multiple prefix from other routing sources. You can limit this one. You can control this one. That is called the external prefix limit. Graceful restart. Graceful restart is a, you can consider it's a uh, just like this. Just consider you have multiple router is connected with each other. So if one router goes down, this down router before down, they just sending messages to neighbors. I will be go down. Okay, I'll be go down. So redirect your traffic according to your topology and no user impact. This feature is called basically graceful restart. So this is the router inform the neighbors before restarting. Okay, it can be restart for manual or schedule restart, or it can be power maintenance or any other events. And it also support bidirectional forwarding detection. BFD. BFD is basically a protocol. It's help OSPF to work out within a very short time. Okay, if you already know, normally OSPF communicate or send hello message um, after 10 seconds, and voice pipe use third interval is 40 seconds. So if one neighbor is goes down, it take minimum 40 seconds to synchronize your voice pipe database. Okay, so if you just know before the whole time, before the hello time, if you have option to know my neighbor is down before a hello interval. Basically, BFD is working in a millisecond. Okay, so BFD basically helps OSPF to detection quickly. This is the main feature of BFD. So this is the feature who is the Junos support. And configure OSPF, how to configure the OSPF for IPv4 is for IPv4 routing environments. If you enable for IPv4 routing, the syntax is like this. Edit protocols voicemail, then you have to mention the area. You have to mention the interface, and you can add interface other options. Okay, and this is the OSPF 3. This OSPF 3 is for IPv4. IPv6, basically IPv6, but you can use for both IPv4 or IPv6 routing parameters. Basically, we use OSPF for IPv4 and OSPF 3 is for IPv6. Router ID. Before configuring the OSPF, you have to define the router ID. But normally, we recommend you should set the router ID manually. Just configure one loopback interfaces with IPv4 IP addresses, and this IP address will be the router ID. Router ID will be the 32-bit number like IPv4 addresses. Okay, this need because when router sending messages, it can be hello messages or other messages. They contain the router identification. This message need the identification. Who is router? I get the message, but who is router sending this message? I need to know. And after discovering this, I want to send the reply message. So in that case, router ID is mandatory. Okay. We recommend you have you should maintain the router ID manually. That is the best practice. So this is the first one. So router ID, WSPF uses the router ID. That means short form is RID to identify the router from which the packet originated. RID is manually defined under the edit routing options, and this router ID will use for others routing protocol also, like BCP, like ISIS. Okay. If RID is not configured, a non 127/8 IP address of the first interface to come online is used to typically loopback 0. If loopback 0 does not have a suitable address, the IP address associated with the first hardware interface is used. This is the automatic mapping. But I again say we should maintain it manually. That is recommended. Okay. Use case, it's a simple topology. Backbone router 2 and router 3 is in backbone area. One area is connected with router 1 and router 2, and another area is connected router 3 and router 4, non-backbone area. This area is 1, another area is 2. You can define the area ID as a decimal format, or you can define as a IPv4 dotted decimal format. Okay, no issue. So configuring voice web is the part one, how to configure the voice web. This is example for IPv4, basically IPv4. Say here voice web. It's very simple. Okay, so we start our lab now. It's the router one. Router one, and the router two, and router three. Right? There now. There is some extra configuration will be here because this is basically previous lab. So in that case, we need to remove some configuration from here. Some extra configuration will be here. So let it go. And last one is let us do. So first one is the interface 0, 1, 2, 3, router 1. 0, 1, 2, 3. For interface is connected with router 1, and loopback, multiple loopback is here. Now let this one. Delete it. and this is the router ID. No need autonomous system here. This need for BGP. This is the OS BGP configuration. Enable this one. No need policy here. Edit and policy delete OSPF import master and routing instance. Is the routing instance configuration secondary. LAN PBR is not defined. Mm, I'm getting this because I applying the LAN PBR here. Another interface LAN PBR is applied here. Your display set very simple. Okay, just IP address configuration. Set the loopback interface and set the IPv4 IP address here and both IPv6 and set the IPv4 address as a router ID. Okay. So second router, no need BGP. So no need autonomous system here. Delete. Store. I need to check OSPF only today. Okay. Not this. Delete. Or you can delete like this. Just go to policy, policy options. Just go to policy options. There is multiple policies here. If you want to delete everything, just delete everything will be deleted under policy options. Okay, display, commit. The interface configuration, IPv4 and IPv6 IP. Loopback address is configured, IPv4 and IPv6, and loopback interface IPv4 address is the router ID. Okay, and last one, you can delete like this, edit protocol BGP, then delete everything under BGP. Edit policy options, delete everything under policy, yes, and delete the routing instance. Or you can apply like this, edit. Every instance will be deleted from here. Set autonomous system, no need this one. No need is static route here. We configure here OSPF. So two interfaces here. Router 3, two interface, physical interface, another is loopback. And loopback interface, no need. Loopback interface is configured as a router ID. Okay, so how to configure the router ID? This is the method. First, configure the loopback interface, and loopback interface IP will be the router ID. That's okay. So if we configure OSPF, First, we need area definition. Voice interface will be in which area. Okay, so consider here, we consider here uh, like this portion will be backbone, and this portion will be non-backbone. It can be any area. Okay, so first I configure router 1. First I configure router 1. Just go set. You can configure like this, or you can configure edit protocol OSPF, and see here OSPF 3. That means OSPF configuration, and another one is OSPF version 3. So now set, there is multiple option. First you need area. Okay, area ID, you can define here area ID. So router 1 will be area 0. I set here area 0. You can set here like this 0.0.0.0 or simply 0. Interface in router 1, loopback interface will be in under OSPF. So LO0.0 you can define, or only LO0, that is sign up. Okay, so see here, and another interface is connected 0, 1, 2, 3. GE dash 0 by 0 by 0. This interface is connected 1, 2, and last one is 3. That's okay. This is your interface. Okay, coming down. A router 2 edit protocol voice PF set area 0 interface LO0 interface. Your interface will be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So copy here 0. 0 will be in area 0. 2. 2 will be in area 0. 1 and 4. 1 will be area 0 and 4 will be area 0. But 3 will be in different area. You can define here area number is 100 and the interface is 3. Okay, so here this router will act as a ABR, area border router. Area border router is connected with the backbone area and another non-backbone area. So our step configuration for IPv4 has been done, and last one is router 3 edit protocol OSPF, or you can configure like this: set protocol OSPF area the area 100 interface hello 0. Number 1. Number 2, your interface is CE-0 by 0 by 3, and last one is 0. Okay, IPv4 for OSPF done. So need to check now OSPF is working or not. Answer OSPF later. OSPF is in full state. That means OSPF is working now. Okay, OSPF is working now, and there are multiple options here. First is address. Say here 10102. I'm in router 1. The point-to-point interface is 0 by 0 by 0 and another interface is 0 by 0 by 2. 0 by 0 by 0. Here 0 by 0 by 0, the point-to-point IP address is 10.100/30. So my neighbor configured 10.102. Basically, this address is the neighbor IP address. Okay. And this address is also the neighbor IP address. This is connected with G0 by 0 by 2. And point-to-point IP address is 10.104. 6 is configured router to G0 by 0 by 2. So first options, this address is the neighbor address. Interface, this option is the exit interface. And state, this state is the OSPF state. And if OSPF state in full, your route transaction will be happened. Other than this state, OSPF route transaction will not happen. Will not send a packet through OSPF routing protocol. Okay, and this option is the ID. ID is basically 10.10.2. 10.10.2. This is same because router 2 router ID is 10.10.2. This router is connected with router 1 with multiple link. Basically, neighbor is between router 1 and router 2. Here we getting multiple neighbor because of multiple link. And the priority, default priority is 1 to 8. OSPF use priority to define the designated router and backup designated router. And this is the dead interval. Okay. So if I see these details like this, this is the neighbor and the exit interface. This is the stat, ID, priority, dead. I'm in area 0. I'm here designated router. And designated router is 10101 and BDM backup designated router 10102. 10102 is the backup designated router. Okay. Similarly, this one and this neighbor up for 3 minutes 26 seconds. Adjacent make 3 minutes 22. Topology default ID is bidirectional. Communicating bidirectional. So here we see designated router and backup designated router because we define the interface. We define the interface under the voice by protocol, but we don't mention the interface type. By default, OSPF consider the interface is LAN. Interface is LAN or broadcast. Okay, if I say in the output like this, interface, say here, multiple interfaces connected and the state is there, designated router. All are in area 0 and this is the router ID and backup designated router ID is like this. So if you mention any single interface like Z0 by 0 by 0 and say the details, you can see here the interface type is LAN. LAN is equal to broadcast. If you consider the broadcast, network type is broadcast, OSPF participate in their designated router and backup designated router election. Okay. designated router and backup designated router election. So this is the election identification, and this is the priority. You can set a priority greater than 1 to 8. That will be the designated router. Highest priority will be the designated router. And also discover here MTU, maximum transmission unit, and the OSPF cost. And OSPF cost is 1. So by default, the interface OSPF cost is 1 for Juniper. Okay. So adjacent is single. The hello interface is 10 and dead interface is 40 and retransmit interface is 5. This is the default. You can modify this one, but you have to maintain same with other neighbor. Otherwise, neighbor will go down. Okay. And MTU is important. You have to maintain same MTU between your neighbor. Otherwise, voice goes down. You should consider the area. Area must be same between one neighbor to another neighbor. Okay. So if I consider here like this protocol OSPF, this interface is basically directly connected with router 1 and router 2. There is no switch here. This link is directly connected with from router 1 to router 2. So you can define interface options here. You can define the interface options here. Okay. If you define here interface option like this, area 0, and the interface is G0 by 0 by 0 and G0 by 0 by 2. This is basically directly connect with another neighbor. So you can define here. Okay. Interface, you set the interface name and you can set here interface type. So interface type can be NBMA, non-broadcast multi-access, and P2MP, point-to-multipoint, and another one is P2P. This is basically P2P, point-to-point. This is not point-to-multipoint. Okay, so you can define here P2P, point-to-point. So there is two interfaces connected with remote neighbor. One is 0 and another port is 2. You can also define this one. So, okay, come with this one. I will show SPF neighbor. No neighbor is here because what is the reason? Reason is this. In router 1, you said the interface type is P2P, but in router 2, interface type is LAN. There is interface type mismatch. That's why OSPF goes down. So you need to maintain this. Interface type should be same between neighbor. Okay. Edit protocol OSPF. So set area 0. My interface will be 0 and 2. Interface 0 and interface type will be P2P. And another interface is 2. Interface type will be P2P. And another interface will be this one, 100. And interface is 3. And interface type will be P2P. So see here, comment this one. I can check the neighbor. Yes, neighbor is up. Neighbor is up right now. And if you see the interface details, if you see now the interface details, extensive, see here, no designated router, no backup designated router here. Okay, and interface type is P2P. There is no priority here. There is no priority here. Okay. So now, if I see the any other interface except the point-to-point interface like loopback, like LAN interface 001, 002, okay. So if I change here one, see here designated router ID, backup designated router ID, okay, and the priority value and type is LAN. Okay, that means this interface initiate voice message in LAN, but this device don't know the voice stream, don't know the voice stream, but initiate the message from 1 and 3. Both are in LAN interface. So you no need to send any voice message to LAN. No need. So in that case, you can optimize this one like this. Set area, the LAN interface that will be passive. And another interface is 3, 1 and 3 that will be also passive. No need to send OSPF related passes using this interface. Okay, no need to send. See here, dear ID, no dear ID here. BDR ID, no BDR ID here. There is no communication. Adjacency count is 0, and the interface is declared as a passive. Okay, passive. No voice web communication will be happened here. So if you set this parameter in neighbor interfaces, if you set this passive option in neighbor interfaces, your neighbor will goes down. You have to maintain this one. So don't set passive keyword in neighboring interfaces. Passive keyword will be loopback interfaces and all LAN interfaces. You can say that will be optimization of OSPF. Set loopback 0. You can set here passive. Set area 0. Interface hello 0. Passive. You can set here passive. So if I set passive in point-to-point interface, your neighbor will goes down. So see here the Westpac neighbor status, run show Westpac neighbor. One neighbor goes down. This is 0 by 0 by 0 because of passive keyword. Because of passive keyword. So no need to use passive keyword in neighboring interfaces. Commit this one. Westpac neighbor shape up. So this is basically Westpac configuration. And if you go to router 2, you can set here area 0, interface, loopback 0, and the passive. And LAN interface here, I mean router 2, LAN interface is 1 and 4. So you can set the interface 1 and 4, 1 and 4 will be passive. 1 and 4 will be passive. So that's all. Point-to-point interface is P2P, and line interface and loopback interface will be in passive. So that's all. Coming this one. So that's the last one. Edit protocol. SPF. Show here. You set same options in router 3. The loopback interface will be passive and P2P interface or neighboring interface will be P2P, P2P, and the LAN interface will be passive. That's okay. So first check the OSPF neighborship. Show OSPF neighbor. Yes, my two neighbor is off. Router 2, here is 3 neighbor, 2 neighbor with router 1 and 1 neighbor with router 3. That's good. Okay, so back to our slide. This is the basic configuration. We already test this one, and we see here another options is metric. See here is the metric. Why we use metric? Basically, we use metric to set the primary and secondary path. Okay, so see here in router 1, run show route protocol OSPF. From OSPF, we get multiple route here. So consider this route. Consider this route. Okay, this is third. Run show route. This is the destination route, which is installed in inet.0 route table, and this is the active route, and this route is coming through OSPF routing protocol, and the OSPF preference is 10. OSPF internal route preference is 10, and if this route is in external route, if this route is external route, that will be 150. So this route is basically coming through as a internal route. Its preference is 10, and this is basically time. Route installed in route table. This is the time, and say here the metric. Say here the metric. Metric is 2. I'm getting this route from router 1. So how metric 2? How it take 2? Basically, one interface cost is 1. That is metric is 1. Another interface cost is 1. So 1 plus 1, I see here 2. I see here 2. Okay. And see the scattered side. This path will be the forwarding path, but this path will not be the forwarding path. This is in route table, but this path will be in forwarding table. Okay, so you can say route forwarding table, destination, destination. If you set this destination, say here the forwarding in forwarding table, this next step is a here. Okay, so this is the traffic path. If this path goes down, that will be the active. Okay, so that case, if you want to make This will be the primary path and this will be the secondary path. So you should maintain the metric value. You should mention the metric value. Default metric is 1. This is 002. This is 002. This default metric is 1. If I set here, the metric is 2. So 2 interface 2 metric is 2, but interface 0 metric is default. That means 1. So 1 plus 1 total 2, and throw interface 2 metric will be 3. So that will be the secondary path. Okay. So if I set here like this, areas 0, I want to make interface 2 as a secondary path. So set here metric. You can set the metric, and metric value will be 1 to 65,535. So I set here 10. So say here is the metric. So comment this one, and also set here interface set area 000, and interface is 2. Metric will be, I use here 10. So metric 10. Comment this one. So select the route now. See here, metric 2. 10, 10, 10, 3, 32. Metric 2 in route table. Metric 2 in route table. If just consider here, your interface goes down. This interface goes down. Interface disable. Okay. The interface goes down. So backup will be available. See here, the metric is 11. I set here 10 and 1 is coming, adding here because of router 2 and router 3 interface carrying the metric value 1. That's why the material is 11. So if you want to make a primary and secondary path, or if you maintain a failover path, so you can use the metric value. Okay. So I delete the disable command here. Just having the interface. I hope OSPF will be off and primary path will be activated. Okay. This is the uses of metric to define the primary and secondary. Metric interface. This does say here in slide they don't use the interface options, passive options, interface type P2P. Increased matrix secondary path. Metric is used to select the secondary path basically. Okay, it's the basically same configuration. And configuring OSPF part 2, this is basically uh, metric. It's the calculation of metric. You can set also the reference bandwidth manually. We don't recommend to change this value basically. So if you want to change, you can. Okay. Redistributing the route. If you want to redistribute some route which is coming from another routing information sources, it can be direct, it can be any other routing protocol. So you have to deploy the policy and apply this policy in OSPF export policy. In that case, your route will be redistributed. Okay. This is the way. So consider here Say in router 3 LAN is connected in C 0 by 0 by 0, and the IP address is 3.0/24. If I check here the route in router 1, run show route 10.1.3.0/24. This route is coming through OSPF. Okay, this route is coming through OSPF. If I just delete the interface, basically LAN interface, if I delete the LAN interface here, LAN interface not included here in under OSPF. Okay, so commit this one. My route will goes. Now route is not here. I'm getting the route as a preference stand. So this route is here. This route is here, but not getting through OSPF. Okay. This route is here. This route type is direct. Okay. So if you want to send the any other routing protocol route, so need some policy. Need policy. Set export. So you export to OSPF. This is the sample policy name. Policy is not defined. You can define policy here. Edit policy option, policy statement, and this is the policy name here. Set term 100 from route filter. You can define 10.1.3.0/24. This is your route. This is the exact route. And this is exact. And then exact. Set from 1000. Then basic. Say here, you create the policy, matching the interested prefix, which you want to redistribute in OSPF routing domain. So see here, 3.0. Yes, 3.0 is coming in a net.0 route table, and the preference is 150. Preference is 150. This route is basically OSPF external route. OSPF external route or redistributed route. Okay, OSPF external, or you can say that this route is redistributed route because its preference is 150. Okay, so when you configure the policy, so if I just adding some options in under the policy options, set term 100 from, you can set any other options. You can set your protocol. You can match here. Okay. You can match your protocol. Okay. So this route is coming from protocol is direct. Okay. So you can mention here direct, directly connected route. So this route is direct, and this route 10.1.3.0/24 is the direct route. Both is true. Both is true. In that case, this route will be advertised. Okay, no issue. So you can mention here any other options like what can I say? You can say interface. Okay, interface. This route is coming from interface is the 0 by 0 by 0 CE. dash 0 by 0 by 0. You can say here, no issue. Direct interface will be this and prefix will be this. All are true. If anyone is false, like set protocol, set term 100 from protocol static. Protocol is static. You delete from 100 from protocol. Delete. You delete this one. Okay. This is false. This is true. This is true. True, true, false. And operation is false. So if you see here, route is not here because of wrong policy. This is basically wrong policy. Okay. So when you configure the policy, you have to maintain some rules. Delete from 100. And which one is false? This one is false. This one is false. So I delete the false one, commit the configuration, and getting the route. Yes. Okay. This is the process how to redistribute any other routing information route to OSPF. Okay. So OSPF use two preference. So one preference is 10. 10 is the internal route, and another preference is 150. That is the redistributed route. This is the identification of OSPF different type. Okay. So if you just use the passive is basically not sending OSPF messages. So in neighboring interface, don't use passive keyword. I use passive keyword in loopback interface and the LAN interface. Okay. So this is the monitoring, how to monitor, how to verify the OSPF. This is the very basic command, show OSPF neighbor. And this option, first option is neighbor, and the second option is exit interface. The OSPF is tight, and the OSPF router ID, priority, and dead interface. And another keyword you can use show OSPF neighbor extensive. This will basically show you detailed information of neighbors. Okay, I already show this one, and this is the uh, basically details of this command. First one showing the neighbor address, display the address of the neighbor, and second one is interface, which interface is connected with neighbor, the state, full state or any other state. It can be any other state. OSPF use this state basically attempt, down, exchange, extra, X start, full, init, loading, or two-way. This is a multiple state. When your neighbor is in full state, OSPF will be operational. In some cases, two-way state, when your network traffic is broadcast on LAN, dear other to dear other, the voice web neighborship will be the two-way. In that scenario or in that topology, the voice web state is okay. This is the voice web priority. Basically, this is the voice web neighbor extensive command detail. Already show you the designated router. I already discussed designated router, backup designated router, access and uptime, everything. If you want to clear OSPF neighbor, you can use this command, clear OSPF neighbor, or you can mention the neighbor address here. Okay. Sometimes need to refresh the OSPF neighborship. In that case, you can use this command. Okay. So This is the verification command. Basically, I already show you, show out, and this is the destination IP address. One is say you have 150. This is the redistributed route, and this 10. This is the voice web internal route. Okay, multiple monitoring commands here. Show web interface, show web route, show web database, show web statistics, show web log. It's the various command to troubleshoot voice web neighborship or collecting the log. Why web not why not getting any specific route? Okay, so this is the basically show command details. Okay, show web interface, MTU cost. So we already discussed this one regarding voice web interface. Basically, any new thing here? Show voice web route. This is the basically voice web database section. You can check voice web external route, voice web internal route, or intra route. Inter route means to say this route is coming from another area. Intra means this route is coming from in area. Is the basically definition or naming convention. Show voice web route. Say here the voice web route type. External. This is redistributed intra in area, and inter. This is coming from another area. Okay, and this is the metric value. Default metric value is 1 for interface, and you can set the metric value to define the secondary path. Okay, and this is the voice web database. Okay, link database other options. Basically, there's no new options, and link type we already discussed, point to point, and other link type. Show SPF log. Basically, here we show the OSPF area type, different area type. You can see from show OSPF log. And, this all are verification command. Show OSPF statistics. You can check hello is sent or received 5 packet. OSPF basically send and receive 5 packet. Hello, DVD. Link state request, link state update, and link state acknowledgement. See here, send and receive. That means both way communication is happened. Okay, troubleshooting OSPF. If you want to troubleshoot OSPF, you have to enable the trace options. In trace options, you can include a specific event or a specific error, or you can add here all options to get all event or all log regarding OSPF in from this router. Tra- Basically, trace option is equal to debug if you consider with Cisco. Okay, then you can see the log message from trace options. Sometimes when we troubleshoot some neighborship, somehow WhatsApp membership not up, then need to analyze the log. So in that case, you have to enable the trace options. Okay, trace option will help you. Why WhatsApp not up? Okay, so if I enable the trace option, edit protocol, WhatsApp, say here, set trace options. Okay, then there is two options. One is file, and set the file name here like TRSC trace OSPF and flag. So there's multiple flag here. You can set all. I set here all. All log will be stored in this file. The file name is trace OSPF. So commit this one. So run show log message. This is the default file, but I stored the OSPF log in the trace OSPF in this file. This is a separate file. Okay, this all related to OSPF. Okay, so you can analyze this log record and identify the problem. Okay, so similar, we configure here OSPF 3 configuration, basically same like OSPF. Display set, top, edit protocol, OSPF, show, show display set, top. So go to edit protocol, uh, better. If I edit protocol OSPF, show display set relative. That will be shortcut. Edit protocol OSPF 3. I mean OSPF 3. That means for IPv6, just copy this one. For IPv6, configuration will be similar. Okay, no changes. No changes here. No changes here. Okay. OSPF 3 configuration done. Then commit. Then go to router 2. Go to OSPF section. Show display set relative. Then top edit protocol OSPF 3 and copy this command. Last one, edit protocol OSPF. Show display set relative. Edit protocol OSPF 3. Okay, and set the command here. OSPF for IPv6 now ready. So OSPF 3 neighbor. Yes, getting to neighbor. And OSPF neighbor, OSPF use link local IP for neighbor discovery, not use the point-to-point IP. Okay, my two neighbor is here. Router 2, I'll get the 3 neighbor, and router 3, I'll get the 1 neighbor. Okay, similar, show OSPF 3, you can see here all options here. Route, yes, all are OSPF route. Some are intra, that means in area, and some are inter, that is coming from another area. See here, this router 3 loopback, this coming from another area. That's why this route is enter. So you can check here overview. Router ID you configured. LSC refresh time is default is 50 minutes and the area is configured here 0. No special area configured here. Neighbor is up and neighbor is in full stat. SPF shortest path First, algorithm is executed in 6 times. Okay, so you can verify other details like IPv4. You can check interface. You can check statistics. Statistics, you can see here the packet type, Wi-Fi packet type. Packet is sent and received. That means communicating. No issues here. Then you can say database, Wi-Fi 3, link local database. So one is router LSA and the interprefix or interprefix LSA. So that's all for OSPF, how to configure the OSPF and OSPF 3 for IPv4 and IPv6, how to monitor, how to verify. Okay. Is there any query regarding this topic? Okay, no query. So I stop now.